Hi, welcome to your notes on right triangle trig ratios. So there are three basic trig ratios that we'll be working with. The first is sine, and that's abbreviated SIN, but still we call it sine. Then we have cosine. We write that as COS. And then finally we have tangent. And we write that as TAN. When we write our trig ratios, we write it as a ratio of the sides in reference to one of the acute angles. So sine of an angle is the opposite side over the hypotenuse. Cosine of an angle is the adjacent side over the hypotenuse. And tangent of an angle is the opposite side over the adjacent side. So when we look at angle A, we know that side BC is the opposite. We know that side AB is the hypotenuse because it's opposite the 90 degrees. And then side AC is the adjacent side because it's basically the other part of the angle. So the sine of angle A is the opposite over the hypotenuse, or 3/5. The cosine of angle A is the adjacent side over the hypotenuse, so 4/5. And the tangent of angle A is the opposite side over the adjacent side, or 3/4. Now all of this changes when we go to angle B. When we look at angle B, the hypotenuse stays the same because it's the opposite 90-degree angle, but now side AC becomes the opposite, and side BC becomes the adjacent side. And so then the trig ratios change. So the sine of angle B is the opposite over the hypotenuse, so 4/5. The cosine of angle B is the adjacent side, 3 over the hypotenuse, 5. And the tangent of angle B is the opposite side, 4 over the adjacent side, 3. We can use these ratios to find missing values in our triangles. So if we look at example number 2, we are given an angle, that's 25. We're given the opposite side, and we're given the hypotenuse. Since the sine of an angle is the opposite over the hypotenuse, we'll use the sine function and say that the sine of 25 is equal to x over 15. And then we'll solve that by multiplying both sides by 15, and we'll get that x equals 6.34. And we'll round everything to the nearest hundredth as we go through these problems. In example 3, we're again given an angle, but this time we're given the opposite side and the adjacent side. The trig function that deals with opposite sides and adjacent sides is tangent. So we'll say the tangent of 40 degrees equals 6/x. We'll multiply both sides by the denominator, which is x. And then we'll divide by the tangent of 40, and we'll get that x equals 6/tan 40. This is what we're going to type into our calculator. We'll wait until the very end before we turn the tangent of 40 into a number. And once we type 6 divided by the tangent of 40 into the calculator, we get 7.15. In example 4, we're again given an angle. This time, there's our angle, but this time we're given the adjacent side and the hypotenuse. So we'll use the cosine function. We'll say that the cosine of 68 is equal to 10/x. And again, we'll multiply by x and divide by the cosine of 68. So we get x equals 10 divided by cosine 68. So x equals 26 39.69. Moving on to example number 5, in this case, we're not given the value of the angle, but we are given the value of both sides, the opposite side and the adjacent side. So to find missing angles, we're going to use the inverse trig ratio to solve the equation. So we'll set it up the same way. Tangent of the angle, which is x, is equal to the opposite side 4 over the adjacent side 7. Now, to get the angle outside of the tangent function, we'll do the inverse of both sides. That'll give us x on the left, and then we'll literally type the inverse tangent of 4 over 7 into the calculator, and it will tell us that x is 29.74 degrees. Okay, example number 6, we are again given a missing angle, but two sides. We're given the adjacent side and the hypotenuse. The trig function that we need to use is cosine. So the cosine of the angle is equal to the adjacent side over the hypotenuse. Again, we need to use the inverse function so that we can get the angle outside of the trig function. So inverse cosine of the cosine of x is equal to the inverse cosine of our ratio 10 over 13. When we type the expression on the right into the calculator, we get that x is 39.72 degrees. And don't forget that you need the degree symbol. Okay, 2 more examples. For number 7, again, we're looking for an angle, but we're given the opposite side and the hypotenuse. So opposite and hypotenuse is the sine function. We'll say the sine of x equals 6 over 10. We need to get the angle out of the sine function by using the inverse. And we'll get that x equals 36.87 degrees. Okay, last example. In this example, we're actually given the angle, as we were in the first view, and we need to find the missing opposite side, but we're also given the adjacent side. So we'll use the tangent function and say the tangent of 55 degrees is equal to x over 10. Multiply both sides by 10 and get that x equals 14.28. We don't need to use the inverse trig function because we're given the angle, and we don't need to put a degree symbol on here because we didn't find an angle, we found a side. At the bottom of the notes is a way to remember the different trig functions and which sides they incorporate. Since sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, we use the expression so, ka, toa to remind ourselves which sides and go with which trig functions. As always, let me know if you have any questions.